Okay, so we're going to be moving on to some of the things for exercise 10F, and at this time we begin by having a look at quadratics with sine, cos, and tan in. So we had come across this idea before, but I'm just going to read through what we've got written at the top. It says, we saw that an equation can be a quadratic in something, e.g. something like x minus 2 root x plus 1 equals 0. This is a quadratic in root x, meaning that root x could be replaced with another variable, say y, to produce a quadratic equation. So in this case, instead of it being x, it would be a y squared, and instead of it being minus 2 root x, it would be minus 2y, and the plus 1 stays the same. So we actually called these, when we did this earlier on, we called these pseudo quadratics. And they were pseudo quadratics because they weren't like a traditional one. Pseudo means kind of like a fake version. So they are quadratics, but they're just not the way that they would traditionally look. And actually, we get these pseudo quadratics, which are actually in either sine, cos, or tan. And we just need to be careful about the way that we might solve these kinds of equations that we have. So hopefully, when you see this equation that we've got written here, 5 sine squared x plus 3 sine x minus 2 equals 0, hopefully we can recognize that this is a quadratic that we have here. So if we were going to do this the slightly slower way, what I would say here is I would say let y equal sine x. So that way, y squared would be sine squared x. And so we could replace 5 sine squared x plus 3 sine x minus 2 equals 0. We can replace the sine and the sine squared with y to get 5y squared plus 3y minus 2 equals 0. And then, as you know, you have quadratic equation solvers in your calculator. So I'm actually then going to go straight to my graphics calculator here, or your ClassWiz calculator. And I'm going to solve it with the coefficients being 5, 3, and minus 2. So this then gives me that y is equal to 2/5, or y is equal to minus 1. Now we're trying to solve this equation here for x. But actually what we've done so far is we've found solutions for y, so we haven't quite finished. We now need to make sure that we use this to replace the y's that we have down here and down here. So this one will change to sine x equals 2/5. And then we can just go about solving that equation in the usual way. So our first value for x is going to be arcsine of 2/5. And I will just grab my calculator here and let's clear all of this. So I'm going to do the inverse sine of 2/5, and my answer is 23.6 degrees. And then if I want to find my second solution, we know for sine, you just do 180 minus the answer, and so we get 156.4 degrees. That's only been dealing though with this first one that we've got here. So we also need to make sure that we deal with the second part too. So I will replace the y with sine x again, and we get that sine x is equal to minus 1. Now if you wanted to, you could do the inverse sine of that, or what you could do is you could think about your sine graph either like this and think about where does it equal minus 1, or you can think about your cast diagram and you can think, okay, well the sine is how much up or down that it is going, so the only place where that would be equal to minus 1 is when it's down here, which is this angle of 270. And again, you can see that this would also be 270 over here. So our answer for this one is that x is 270 degrees. I'm just going to confirm that for you by doing the inverse sine of minus 1. And you get minus 90 from this version of the calculator. And we know that you can also do 180 minus that. Whoops. 180 minus the answer, and you do get 270 as well. And so these are all of our solutions for this particular one that we have here. I'm just going to write them out as a list so that we have them all together. So we get that x is 23.6, 156.4, and 270 degrees. Okay. I am going to just very quickly show you how you don't have to do this section here with it as y. if you can spot that this is a quadratic from this stage, you could go straight to your equation solver on your calculator, and for your quadratic, which on your calculator will come up as ax squared plus bx plus c equals 0, you can clearly see that a is 5, that b is 3, and that c is -2. You can put these straight into your equation solver, and it will give you the solutions 2/5 and -1. The only thing you have to notice here is that this is not the answer. This is not x equals 2/5, but this is sine x equals 2/5 and sine x equals -1. And then you go about solving the equations in the same way as before. So I'm going to do another example now on the next page. Okay, here we have an equation that is tan squared theta equals 4, and the interval is still between 0 and 360. Oh, this it shouldn't actually say x, really. This should actually say theta so that it matches the question. So the first thing that we're going to need to do is to make tan theta the subject, and that is done by taking the square root of 4. Now the square root of 4 has two options. You have plus and -2. So I'm actually going to write this out as two separate equations. We're going to say that tan theta is equal to 2, or we've got that tan theta is equal to -2. So I'm going to start off by doing this side over here. So theta is going to be the inverse tan or arctan of 2. Let's grab my calculator. So we'll do the inverse tan of 2, and we get 63.4 degrees. And we know for tan, you can just add 180 onto that answer, and we get 243.4 degrees. And there's not going to be any more inside this region that we've got. Sometimes it's easier if we just draw a line so we can spot what's going on. So I'm now going to do the inverse tan of -2. I'll put some brackets there to make it clear what's going on. And I shall go back to my calculator. So I'm going to do the inverse tan of -2. Now we've got -63.4, but that's not inside our range. So we're not going to include that one, but we are going to keep adding 180 on to see what we get. And we get 116.6. Let's add on 180 just to see if we have any other ones inside that range, and we do. We've got 296.6. 296.6 degrees. Now, because this one here is out of the range, I can simply put a cross through it, and that is all of my answers that I have. I'm just going to show you this one on Desmos, just because I think it's always interesting for us to check this. You know how to check it on your calculator as well. So what have we got here? Tan squared theta equals 4. So I'm going to go to my functions, and I'm going to type tan of x. Now actually on this version of it, you can actually put the square sign in here, which you can't do on your calculators, but you can on Desmos. And I suppose I should have been saying at the beginning y equals tan squared x. And the other one is when it is equal to 4. So I'm going to say y is equal to 4. And it's popped up here. The range in this one, I think in the question, was 0 and 360. Is that right? Yep. So I'm just going to shrink my axes, so I've got it between 0 and 360. And we can see the places where it's crossing is 63.4, 116.6, 243.4, and 296.6. So we have got all of those solutions. I'm hoping you are using this Desmos or your graphics calculator when answering these questions. Okay, here is where things get different. And I'm wondering if you can spot why this one is different. So in this first example that we had here, we had a pseudo quadratic. Let's just have a bit of time to think about this question and why this one is different. Okay, so at the moment, this one is not a pseudo quadratic. Okay, there is a problem that means it is not a pseudo quadratic. And the reason why is because we have got some stuff which is sine x, and then we've got something else which is in cos x. And usually our strategy for combining sine and cos would be to create tan, but that won't work in this case. If you just try dividing everything by cos, because that's usually how we do this, you would just get 2 cos x plus 9 tan x equals 3 sine x tan x. And we're kind of stuck. Oh, sorry, that wouldn't be cos squared x, that would just be cos x. And then if you divide by cos again, it's just not going to work. Okay, so we can't do that technique. What we're going to have to do instead is we're going to have to use an identity. We are going to use the Pythagorean identity. And we use the Pythagorean identity when we have sine squareds and cos squared x, and a sine x or cos x, and you'll see what will happen at the moment. So in this particular case, the one that we're going to be able to change is we can change this cos squared x, we can change it to sine squared x somehow. We can change it to sine squared x using the Pythagorean identity. And I want to change the green to become one of the yellows because of this sine x that I have here. This sine x is going to have to stay as a sine x. So the thing that I'm going to try and do is to change the green one so that it can become in terms of the yellow one, so that it's all the same as sine x. Okay, a quick reminder of the Pythagorean identities. We know that sine squared x plus cos squared x is equal to 1. And as a variation of that, we know that cos squared x is 1 minus sine squared x. And we also know that sine squared x is 1 minus cos squared x. So I'm going to go straight into this equation that I have here, which says that 2 cos squared x plus 9 sine x is equal to 3 sine squared x. And I'm going to start off by replacing this cos squared x that I have here with this identity that I have over here. So we get 2, and I'm replacing cos squared with 1 minus sine squared x, plus 9 sine x equals 3 sine squared x. Expanding the brackets, that's 2 minus 2 sine squared x, plus 9 sine x equals 3 sine squared x. Now this, I'm hoping you're starting to recognize, is a pseudo quadratic. It is a type of quadratic. And the way we solve quadratics is we get everything on one side and make it equal 0. So this ends up with 5 sine squared x, adding the minus 2 sine squared x, minus 9 sine x, minus 2. Now at this stage, I can recognize that this is a quadratic where my a value is 5, my b value is minus 9, and my c value is minus 2. And so I'm going to go straight onto my calculator here, and I'm going to find out what sine x is equal to. So I'm going to put in my a value is 5, b is minus 9, and c is minus 2. And here we get that either sine x is equal to 2, or sine x is equal to minus 1/5. Let's just zoom in so I've got a bit more space here. And I'm just going to put that in a separate area. Now, sine x equals 2. If you think about this, what the sine graph looks like, and this is right back in chapter 9, we know that the sine graph only goes between 1 and minus 1. So if you're trying to say where does it equal 2, well, we're trying to say where do these two curves, this curve and this line, where do they cross? And they don't cross. So this actually has no solutions because sine x is only ever between 1 and minus 1. So there's no solutions there. And if you do that on your calculator, I'm going to just clear this and show you. If I was to do the inverse sine of 2, ooh, that's very strange. Oh, here, no, it's not strange. We've got an imaginary number in here. I'm not sure if you can see the I at the end. So this doesn't have any real solutions. So it says I, and if you do that on your calculator, it will sometimes say math error. Don't write down math error. Instead, write down no solutions. So for this one, we can continue. We will say that x is going to be the inverse sine of minus 1/5. And so let's come up with our two answers. So we are going to do the inverse sine of minus 1/5, and we get minus 11.5 degrees, minus 11.5 degrees. And actually, if we remind ourselves of this range that we've got, that one is going to be okay. So I'm still going to continue though. I'm going to do my 180 minus the answer, and I get 191.5. So I have 191.5 degrees. Now we need to make sure that we get all of the different values that are possibly going to be here. So I'm going to start off by looking at this minus 11.5, and I either need to add 360 or take away 360 from it to see if there will be any other solutions. I don't know if there are going to be, but I just want to confirm to you that there possibly won't be. So I've got my minus 11.5, and if I add 360 to it, I go to 348, which is well outside the range. And obviously, if I take away 360 from it, it also goes below the minus 180, so that one's going to go outside the range too. I'll just show you with 191.5 as well. So if I do 191.5, if I take away 360, will I get a solution? Yes, I do. I get minus 168.5. So if I just do this in my green color, if I subtract 360 from this, I get minus 168.5. But if I add 360, I go to much bigger than the 180-degree range. So the final answers that I have for this one, if I just put that back over here, are minus 11.5, 191.5, and minus 168.5 as well. Okay, so I'm going to just show you this one using the quadratic solver, not the quadratic solver, but show you using the equation solver on my calculator. So I'm just going to go across to my camera, which is up here, just disappeared. Okay, so we're going to go to Run Matrix, and we're going to go to Options, then Calculate, Solve N. Now I need to remind myself what the equation was. So it's 2 cos squared x plus 9 sine x equals 3 sine squared x. So it's 2 brackets cos x squared plus, what was it again? 9 sine x equals 3 sine squared x. 9 sine x equals 3 brackets sine x squared. Then I'm going to do comma. The variable is x, and I want it to be between minus 180 and 180. Close off the brackets and press equals. And we have got, I prefer to see them as a list, minus 168.4 and 11.53. Now, why is that we don't have the one? Oh, of course we don't have the 191.5. Silly me. When I said this one earlier, this is why it's good to use the calculator. We don't have this. This is not a solution. So hopefully you were telling me this earlier. This cannot be a solution because it is outside the range. So there are only two solutions. Good job I used the calculator there. The only two solutions are minus 168.4 and minus 11.5. That is exactly why we need the calculators to do this checking. Okay, so we're going to do one more of these kinds of equations that really pulls everything together. So we can tell it is some kind of Pythagorean identity that we need to use here, and that's because we've got a mixture of coses, and we've also got a sine squared in here. Now this time we have a cos 2x, so I'm going to try and change this one. I want to change into something to do with cos squared 2x, okay? So we have cos squared 2x minus cos 2x minus 1 equals, now sine squared is the same as 1 minus cos squared. And a mistake people might make is they might say cos squared x, but it's actually got to stay, the argument in all of this question is 2x. So it's going to be 1 minus cos squared 2x. And I'm going to make everything equal to 0 by adding the cos squared onto both sides. So I get 3 cos squared 2x. I still have my minus cos 2x here, and I'm then going to have minus 2. Now, if we wanted to do this the slow way, we could say let y equal cos 2x. So we have then 3y squared minus y minus 2 equals 0, if you wanted to solve the quadratic in that way. Or what you could do that would speed things up is you can spot that on your calculator for the quadratic, a is 3, b is minus 1, and c is minus 2. So if you're not sure how to do that on the graphics, I'm just very quickly going to switch over to my calculator again. So you go to the menu, and then you go to equation, and you go to polynomial. It's a 2-degree polynomial because it's a quadratic, and now you can see what I'm talking about when I'm saying my values of a, b, and c. So I've forgotten already, my brain is really not good today. So it's 3, minus 1, and minus 2. Minus 1 and minus 2. And so the values that we get for this are 1 and minus 2/3. So this tells me that cos 2x is either equal to 1 or cos 2x is equal to minus 2/3. We're going to just proceed almost as though this is like two separate questions to come up with all of these solutions here. So first of all, we've got that cos of 2x is equal to 1. I've just spotted something that we might need to deal with. Our argument is 2x everywhere, and this bit is to do with x. So the first thing I'm going to do over here is I'm going to change the range. So at the moment, it is between 0 and 180, but my argument is 2x, so it's actually going to be between 360 and 0 instead. Okay, so we've got that cos of 2x equals 1. So you should be able to know actually what these angles are, but let's just show you that it starts off at 0 is where it's 1, and 360. Again, I guess you could do this in your calculator if you really weren't sure of those in your head. So you can do the inverse cos of 1. The calculator gives you 0, and you know the other answer is 360 minus the answer, which is 360. Now that we've come up with all of those solutions, we can divide by 2 so that we get 0 and we get 180 degrees. For this one that we have over here, there is no exact value, so we are going to have to do the inverse cos of minus 2/3. And so we get, clearing my calculator, the inverse cos of minus 2 over 3, and you get 131.81. So you get 131.81 degrees. And I've done a couple of decimal places there because I'm going to have to do some halving in just a second. Now, the other way I get this for cosine is doing 360 minus the answer, which is 228.19 degrees, and that's to 2 decimal places. Now, there's not going to be any other solutions inside this range that we have over here between 0 and 360, because if I added or subtracted 360 to either of these, it would go outside that range. So I will finish off by going from this line to this line by just simply dividing by 2. So I'm going to do my 131.81 divided by 2, which gives me 65.9 degrees, and that's to 1 decimal place. And my next one I shall do is 228.19, and I'll divide that by 2, and I get 114.1 degrees, and all of my answers here are to 1 decimal place. So in summary, my solutions are 0, 65.9 degrees, 114.1 degrees, and 180 degrees that we have there. Now I'm going to show you how you could put this onto Desmos. So I've got 2 cos squared 2x minus cos 2x minus 1. Okay, let's go back over to here. So I've got 2 cos, I can actually put the squared in afterwards, 2 cos squared 2x. And I've already forgotten it, which is terrible. 2 cos squared 2x minus cos 2x. And then minus 1, I think, right? Minus 1 equals sine squared 2x. So that's going to be one of my graphs, y equals this. And my other one is going to be y equals sine squared 2x. Sine squared 2x. And remember, we're talking about where these two graphs are crossing each other, because it's these two things being equal to each other. It's this one and this one being made equal to each other. So it's about where they cross on a graph. And we're only interested between 0 and 180. So you can see they cross here, 0, here, 65.9, 114.1, and 180. So we have those 4 solutions, which are exactly the 4 solutions that we have down here. Okay, so you have got a question to have a go at here. I think you should pause this question and have a go. This one, you'll notice there's the arguments that are all x, so it's going to be a little bit easier than that previous one that we've just done. So pause the video here, have a go, and I'm going to just continue doing this in just a second. Okay, so part A, it says, show that this equation that we have written can be written in this form. So what they've done here is they've made it a quadratic, and they've made it a quadratic in sine x. And we know how you do that. You're going to take the cos squared and we're going to replace it with the Pythagorean identity, which is 1 minus sine squared x. And you just always need to make sure that's bracketed when you substitute it. Okay, so for part A of the question, we have 5 sine x equals 1 plus 2 1 minus sine squared x. And now everything in this equation is all in terms of sine x. So we get 5 sine x equals 1 plus 2 minus 2 sine squared x. And then I'm going to put everything all onto one side to make it a quadratic. So I get 2 sine squared x plus 5 sine x minus 3 equals 0, which is exactly what they wanted us to show here. Okay, the next part of the question wants us to solve it. Here is my range between 0 and 360. So I'm going to, for part B of the question, I'm going to go to my equation solver on my calculator. We can see that A is equal to 2, B is equal to 5, and C is equal to minus 3 on my quadratics here, my quadratic solver. So I've got 2, 5, and minus 3. This therefore tells me that sine x is either equal to a half or sine x is equal to minus 3. And I'm going to start off looking at the sine x is equal to a half to begin with. So x would be equal to the inverse sine of a half. But hang on a sec, you should know this. I don't even need to write that out. The inverse sine of a half, we know, is 30 degrees because sine of 30 is a half. And my other one is found by doing 180 minus that. So I don't even need a calculator. We have 30 and 150. Now, very obviously, if I added or took away 360 from this, it would not be inside the range. So I'm actually done with those solutions there. Now for this one, sine x is equal to minus 3. Well, I'm hoping you've spotted that this has no solutions. And the reason this has no solutions is because sine x is only ever between 1 and minus 1. So it can never be equal to minus 3. So the solutions for this equation are x equals 30 and x equals 150. Let's just double check that from the mark scheme. Yep, we've got sine x has no solutions, so sine x is equal to a half, and we come up with x equals 30 and x equals 150. So there's going to be quite a few exam questions you can have a look at on this as well. I will put these up on a separate video and I will go through them for you. Okay, thank you.